Hello there, everyone. So far the integration that we've been doing has been very straightforward. We just did the power rule backwards, essentially. So we would add 1 to the exponent and then divide by that. Divide the coefficient by that number. So we were doing the power rule backwards. Well, really integration is just doing derivatives backwards. So we learned all different kind of rules on how to find derivatives. We learned the power rule, which we already did, and the chain rule and the product rule and the quotient rule. Well, how do we do those backwards? So first, this first problem here is asking to find the derivative. If I wanted to take the derivative of this right here, remember you leave the inside alone and we use the power rule on the outside. So I would bring that 3 out front, leave this alone on the inside here, and then my exponent would go down by 1. But then we have to multiply by the derivative of the inside. So we have to multiply by that 2x. So we would have 6x times x squared plus 3 squared. And that would be our derivative. That's the chain rule. So the inside is left alone, you do the power rule on the outside, and then you multiply by the inside. We did that a long time ago. But now what we're going to look at today is how do we do this backwards? If I were to be given this, where I can see the derivative of the inside is on the outside, how do we do the chain rule? How do we integrate the chain rule? So how do I go backwards? How do I find my original? And we're going to do something called whoa, why is that so tiny? I'm trying to make that bigger. Here we go. That's better. Use substitution, which means we are going to take a piece of our equation here and we're going to turn it into the letter u. So what you want to choose for u is the inside of that. Okay, remember how we said you leave the inside alone and then the derivative of the inside goes on the outside. So whatever you would be considered the inside. So the inside of the function here is x squared plus 3. So I'm going to make that equal to u. So u is going to equal x squared plus 3. Now before I go any further, I'm going to take the derivative of this with respect to x. Okay, so this is going to be du dx equals 2x. Okay, so I just took the derivative. Now I'm going to multiply both sides by dx. So du is equal to 2x dx. Okay, so the first thing you want to do is set u equal to what you would consider the inside. Then take the derivative, which gives me that du is equal to 2x dx. So now let's look at our equation. So our equation is 2x times x squared plus 3 squared dx. So x squared plus 3, this is equal to u. That's what we set u equal to. U is equal to x squared plus 3. Now, let's see, what other color haven't I used yet? Purple. Now, after we took the derivative, look at what we get down here. Du is equal to 2x dx. So this and this together are du. So I can rewrite my pink equation as u squared du. This piece in here is u, so that's u squared. And the 2x and the dx, again, I can write 2x dx together as du. So now I have this. So now this, we know how to integrate. I'm going to add 1 to my exponent, making it 3, and then I'll divide by that 3. So I get 1/3 u cubed plus c. And now our final step is just to plug u back in. So I'll have 1/3 times x squared plus 3 cubed plus c. Now I know that seems like a lot, okay, but the more we do this, you'll see it gets a little bit easier and easier. So what you want to do again is take the inside and set that equal to u. Take the derivative, and then we're going to substitute all that in. That's why it's called u substitution. Substitute all that in, integrate like we know how, and then you just put the expression back in for u. So your answer should not have any u's in it. When you're done, all the u's should be gone. We're just substituting it in for a moment so that we can integrate. Okay, so let's do another one together. Okay, so again, I can see that my derivative of the inside would be 3x squared, and there it is on the outside. So I'm going to use the chain rule, but I need to use u substitution to do that. So again, u is the inside. So u is going to be x cubed plus 5. Now I'm going to take the derivative. So I get du is equal to 3x squared dx. So now we're going to rewrite. So this is u. So that's going to be u to the 4th. And then the 3x squared and the dx come together to make du. Now integrate. So we add 1 to our exponent and then divide. And don't forget your plus c. And then we're going to substitute u back in. And that's our final answer. Okay, again, remember we're not doing definite integrals now. There's no numbers here, so you will need that plus c at the end. Okay. So now for our next one, I see two things different about this one. First of all, we have a square root. So the first thing I'm going to do is rewrite that. So I have 4x times the quantity x squared minus 3 to the 1/2. And now the derivative of the inside is 2x, and here I have 4x. So we're going to have to deal with that as well because it's not exact. So the first thing I'll do is pick my u, and remember u is the inside. So u is going to be equal to x squared minus 3. And then I'll take my derivative. Now again, my derivative is only 2x dx. So when I go to rewrite this, you can think of this 4 as almost being 2 times 2x. So now when I rewrite, this 2 is going to stay out front. This piece becomes u, and these two together become du. So I have 2u to the 1/2 du. Okay, again, where does everything go? This is u, so this becomes u to the 1/2. The 2x and the dx become the du, and that 2 just stays there. So we had an extra 2 there, which is fine. Okay, so it's not exactly the derivative, but we had an extra number, so that number just stays there. That's fine. So now again, we integrate like normal. So I'm going to add 1 to my exponent, which is 3/2. So I'm going to have 2 times 2/3 u to the 3/2. Because remember, dividing by a fraction is like multiplying by the reciprocal. And then plus c. So I end up with 4/3 times x squared minus 3 to the 3/2 plus c. Okay, so if you have an extra number there, that's totally fine. You can just split it up into the numbers that you need, and then that number stays there. Now in this next one, we have almost the same kind of dilemma, but instead of having an extra number, we're missing a number. So in this one, again, think about u would be my inside. So u is going to be 3x squared plus 5. So now when I take the derivative, I get 6x dx. Well, this time, like I said, we're missing a number. I'm missing that 6. So I can't integrate until there's a 6 there. So what we're going to do is we're going to add a 6 in there. But I can't just say, oh, I'm just going to add this 6 and now it's the same problem. That's not true. I've multiplied by 6. So to balance that out, what we're going to do is we're going to put a 1/6 out front, because 6 times 1/6 is 1. So we've done this many times before with common denominators or whatever. So really I'm multiplying by 6 over 6. I'm just putting the 6 on the inside of the integral and the 1/6 on the outside of the integral. Because I could put this 1/6 on the inside as well, but I think it's just easier to leave it on the outside. But so I really haven't changed anything because, again, I multiplied by 1. But now when I go to rewrite with my u's, again, this becomes u. So I'll have u to the 4th. And then 6x dx becomes du. Now I integrate. So I'll add 1 to my exponent and then divide. And don't forget your plus c. And now I have to plug the u back in. So I have 1 over 30, because 6 times 5 is 30, times 3x squared plus 5 plus c. Okay? So again, the previous one had an extra number in there. That's fine, just leave that number there. This one was missing a number. So I had to add it in there, but then I also needed to multiply by 1 over 6 so that I wasn't changing the value of anything. Okay. There are 2 more here on your notes. I'd like you to try them on your own. I'm going to stop this video and actually start a new video just to explain those 2. Okay. So go ahead, stop listening to this one, give those other 2 a try, and then you can watch the other video to see how to do them.